Hi everyone, welcome to NunleyMathShorts. I'm Aaron Nunley. Thanks for joining me here today for the first in a series of lessons that I'm creating at my students' request. That's quite a bit briefer than my typical lessons. Ordinarily, when I make these videos for YouTube, I try and include an entire lesson just as I would present it in my class, but a lot of my students are telling me that sometimes that might be a bit overkill for what they need, and often they're looking for just a quick review of topics that we actually discussed in person in class. So this is my attempt to accommodate them. I hope it's useful for you as well. You'll notice that we are starting with changing equations to slope-intercept form. And in my class, we will have talked already about graphing linear equations or linear functions. We define a linear function or a linear equation as any pattern that has a starting point and a constant rate of change. And we talk about the fact that those patterns can be expressed in the form y equals mx plus b. That is the slope-intercept form of a linear equation. Now, we call it the slope-intercept form because if we were to take this number in front of x, this is our constant rate of change, which graphically we're going to refer to as our slope. And this number over here by itself is going to be our y-intercept. So I might tell my students, graph y equals 2x minus 9 on a coordinate plane. And I would hope that they would realize that this number 2 indicates the slope of our line or how fast it's growing. We should be going at a rise of 2 every time we have a run of 1, or we're going to be going up 2 spaces every time we move to the right 1 space. And this -9 in purple over here indicates where we should begin from. Notice I've given it the coordinate 0, -9, which indicates that I'm going to start at -9 on the y-axis. So we begin with our y-intercept or our starting point, and we begin to repeat this slope pattern. I rise 2, run 1, and put a new dot. Rise 2, run 1, put a new dot. Rise 2, run 1, put a dot. And I continue that pattern for as far as I need to go in order to indicate where that line is going to be. And I often remind my students that you need to be very, very careful about making sure you get enough dots so that your graph doesn't start to go crooked here towards the end because you're doing these in a hurry. If you don't mind, I would suggest that you pause the video and try this next one on your own if you think you can. Otherwise, just watch me do it. Again, this is in slope-intercept form. Notice that here in green, -3/5 is my slope. This tells me I'm going to go down 3 spaces every time I go to the right 5 spaces. And the +7 tells me I'm going to start at the coordinate 0, 7. So 0, 7 is clear up here on the y-axis. I'm going to start there. I'm going to go down 3, right 5, and put a dot. And I'm going to repeat that down 3, right 5, and put a dot. Notice that this -3/5, when I wrote it over here, I did put the negative sign on top. It does not matter where you write that negative sign as long as you only use one of them. I've been going down 1 and right 5. I could also go up 3 and backwards 5 by moving that negative sign to the bottom. Up 3 backwards 5 says start here at 7, go up 3 backwards 5. And notice that dot falls in line along with all the others in that pattern. Now, I did do this very quickly because graphing in slope-intercept form is not the focus of this lesson. That would be a previous lesson for us, but I did want to reiterate it very, very quickly because today I want to talk about what happens when we get a linear equation that is not in slope-intercept form. Notice this says graph 4x minus 3y equals 9. This is a linear equation, and if you were to graph it, it would make a straight line. But because it's not in slope-intercept form, we cannot use the method that we just talked about, unless we rearrange it so that it is in slope-intercept form. Remember, I need to have my y by itself equals m times x, some number times x, and then some constant number over here by itself. To get this into that form, I'm going to use the property of equality that we learned back in our single variable equation problems. The property of equality says I can do whatever I want in an equation as long as I do it on both sides of the equation. And I can use that to begin to rearrange this just like we did in our equation solving unit. Remember, my goal is to get the y by itself. I've done two things to this y. I've multiplied it by this 3, or actually this negative 3, and then I've also added this positive 4x onto the beginning. I'm going to begin to work my way backwards through that problem. I'm going to subtract that 4x from both sides. Remember, I can do that as long as I do it on both sides of the equation. You'll remember from that particular unit where we were solving these that if I do 4x minus 4x, it does become a 0, leaving me with just the minus 3y equals, that's right here. And now I've got a 9 and a minus 4x. Because my goal is to put it in this slope-intercept form, I'm going to write the minus 4x first and the plus 9 last. That gets me closer to this pattern that I'm looking for. I still need to get y by itself, so I need to get rid of this times negative 3. How do we get rid of multiplication? I'm going to divide both sides by negative 3. Remember, negative 3 divided by negative 3 makes a 1. That's going to make this into 1y, or y by itself. On the right side, I need to make sure I divide both of these by negative 3. Notice, negative 4 divided by negative 3 makes positive 4/3. 9 divided by negative 3 makes a plus negative 3, or if you wanted to put minus 3, you can. Notice this is now in slope-intercept form. Y equals, this is your m, your slope, 4/3, x plus, this is your b value. I can now graph this on my coordinate plane. The b value tells me where to start. It's my y-intercept. So I'm going to start down here at the coordinate 0, negative 3, and I'm going to use my slope to get the rest of the line. Rise 4, run 3. That's up 4 places from my dot, over 3 places. Up 4 places from my dot, over 3 places. And I'm going to continue that as far as I need to. If you want, you can do down 4 and backwards 3 as well and get another dot. Just make sure you have enough to ensure that your line is straight. Got the idea? All right, we're going to start to go faster now. I would recommend pausing the video and trying to rearrange this one on your own, and then look at the video to see if you've done it correctly before doing your graph. I'm going to assume you've already done that. Remember, my goal is to get the y by itself. That means I need to get rid of this times 2. I need to get rid of this plus 10. I'm going to get rid of the plus 10 first by subtracting 10 from both sides. You now have x minus 10 on the left equals, these 10s become a 0, leaving you with just the 2y on the right. How do I get rid of a times 2? I'm going to divide both sides by 2. Notice this is a 1x. 1 divided by 2 is half x. And then 10 divided by 2 is 5. And 2 divided by 2 is 1. This is half x minus 5 equals y. Remember, in our formula, the equals y is on the left. It really doesn't matter which side we write it on. A lot of people are going to feel more comfortable if I switch that around. That's called the symmetric property. If the two sides are equal, it doesn't matter which side of the sign we put them on. And now I can graph. I'd recommend pausing the video again, try the graph on your own, and then play to see if you've done it the way I'm doing it. My y-intercept is this negative 5. So I'm going to start down here at negative 5 on the y-axis. I'm supposed to rise 1 every time I run 2. So from this dot, I'm going to go up 1 over 2, up 1 over 2, and I'm going to repeat that until I have my line. Let's do one last problem. Y minus 4 equals negative 3x plus 2. This one's a little more complicated, but the idea is the same. I want you to try and simplify it and rearrange it so that y is by itself and it equals mx plus b. I'm going to assume you've paused the video and done that. I'm going to do it pretty quickly. I have a negative 3 here that needs to be distributed. That's negative 3x and a plus 6. I also have a minus 4 that I need to get away from this y. I'm going to add 4 to both sides. That leaves me with y, this is a 0, equals 3x. This is now plus 10. It's in slope-intercept form. Y equals m, -3 is my slope, x plus, there's my b. I'm going to start at my y-intercept. My slope here says go down 3 every time, or down 3 when I go over 1. Down 3 over 1. Down 3 over 1. All the way through. Hopefully this has been helpful for you. Hopefully it has been useful. As I mentioned, this is something new that my students have asked that I try to do, so I'm excited to get their response with it. Hopefully we'll have a whole lot more of these in the future. Because they're shorter, they should be faster for me to crank out, and I can hopefully stay a little bit ahead of the curve on getting these done. As always, thank you guys so much for watching. Take care of yourselves. Bye-bye.